All right, so when you see slope, what pops into your head? Anything? Nothing?
Rise over run.
Rise over run. Good. What variable goes with rise? Y. What variable goes with run? X. Okay? If you're given 2 points, typically x sub 1, y sub 1, x sub 2, y sub 2, how do I find slope? Quick. Good. Or the change in y over the change in x. Sometimes called delta y and delta x. Change in. All right? And that's what? Slope, which we typically call m. I'm sure there's a Greek reason why it's m. I don't know what it is. Now, there's another formula that comes from this. It's so easy. I'm hoping the slope formula is like memorized perfectly. In fact, beyond memory, you just know it. What if I want to write that same equation without a fraction? What do? Clear the fraction, right? Multiply both sides by, right? And if I do that, I'll get this. Right? And that's easy enough to get from the slope formula. Now, here's our line. Here is x2, y2, let's say. And here is x1, comma, y1. But let's say I don't want to just talk about these two individual terms. Let's say I want to talk about this point and all the other points on the line. All of them. Okay? So then what I'm going to do is make a small change. I'm going to make this xy. Now it's a variable. x1, y1 is like fixed. xy represents every point on the line. Every point on the line. So then watch this. If I take this off and this off, this is now an equation for every point on the line, right? That passes through x1, y1, and has a slope of m. And we call this form, what's this? It's a point. Yeah. And what's this? The point slope form for the equation of a line. Now I know. You love y equals mx plus b. Your best friend is y equals mx plus b. We're not going to use that much anymore. This is more useful as we go forward to pre-calculus and calculus. Okay? So, if I'm given 2 points, I can find the equation, or find the slope, using the slope formula. Yeah? What if I'm given some sort of equation? Let's say ax plus by equals c. There's a lousy way and there's a good way. The lousy way is to find 2 points. Take the equation and find xy that works. Find another xy that works, right? And use the slope formula again. But we'll go back to your old friend. Get y by itself. right? And who's this? Slope. If I'm given the equation, if I can get y by itself, the coefficient of the x is the slope, right? And I'm sure you've seen that before. This should just be review, but hopefully it's a good review. Now, if I have 3 points that are what? Collinear. They're all on same line. There are 2 ways to prove that 3 points are collinear. Graphing is not one of them. You and I both know our graphs aren't that good. So can someone give me one way to show that 3 points are collinear? So one way is to take any 2 points and find the slope. Then you take the 3rd point and any of the others. Either one, either this or this, doesn't matter. Really doesn't matter. And if the slope's the same, you're in good shape. Now the points are collinear. Okay? Now, let me talk about another case. Let's say that one point's here. What could you tell me about the new thing I drew? Those purple lines. Anything. Just be random. Triangle. Okay, good. What's the shortest distance between 2 points? Straight line. A straight what? Line. Wait a second. What if I do this? What if you found the distance between these 2 points and the distance between these 2 points? And then you find the distance between these 2 points. What should happen? The 2 small ones should add it to the big one if the shortest distance is a straight line, right? If I take this distance and this distance and this distance, what's not going to happen? They're not going to add up, are they? So I can use the distance formula idea or the slope formula idea. Does that make sense? Okay, what's true about any horizontal line? What doesn't change along this line? The y values. The y values are the same. Horizontal line, y equals some number. Okay? And for a vertical line, what doesn't change? The x value. Now, you want to see something really dumb? This is really dumb, but somebody might like this. If I turn the y upside down, I get an h for horizontal. And if I take the v and put a v here and a v here, I get an x. That's so bad, isn't it? Anyway, and then what's the slope for a horizontal line? 0. You want to see another bad thing? A horizontal line has a slope of 0. Because if you do the slope formula, where's the 0? If you do the slope formula where the y's are the same, where's the 0? On top. Good. On the other hand, if I take a vertical line and do the slope formulas where the x's are the same, where's the 0? On the bottom. What do we call that slope? Undefined. And some books, which I really don't like, but you have to be aware of this, they call that no slope. Undefined, no slope, doesn't exist. Okay? I would think, well, no slope is like 0 slope, and that's so confusing. All right? When a line is parallel, same slope. When are lines perpendicular?
Opposite reciprocal.
Opposite reciprocals. For perpendicular, there's one exception, where they're not opposite reciprocals. You know what it is? Horizontal and vertical. Because if I have 2/3, what's the opposite reciprocal? -3/2. When you multiply opposite reciprocals, what do you get? -1. What's the slope of a horizontal line? A horizontal line? 0. What's the slope of a vertical line? Multiply those two. I don't think you're going to get -1. You know what I'm saying? Okay. So, if I give you a point, and I give you the slope, you should say thank you, because all I have to use is that point slope form for the equation of a line, right? Now there are other versions. There's this one, and that's what? Slope, intercept. And then there's this one, which is maybe like standard or general form. I'm not sure which one they use. But we can have all different kinds, right? But we're saying this is going to be the one we're going to use most often. And who is it again? Point slope. Okay? If I give you 2 points, you didn't see that. What should you find first? Slope. And does the line go through both points that they gave you? Given 2 points and a line through the right, which means it doesn't matter when you use point slope whether you use this point or this point, right? Because how many points are there in a line? Infinite. Just pick one of them with the slope and it will describe all the other points, right? That's what I meant back here. When we switched it to just x, y, that's all the other points. x1, y1 is a specific point. There are different kind of variables, aren't there? This is a true variable, it keeps changing. This one is a variable until you choose it. Then you're stuck with it. See the difference? All right, now, here's a line with an x and y intercept. Here's the x-axis, here's the y-axis. Hopefully you see the triangle that they're talking about. Yes? How do I find the perimeter of this triangle? Yes? Get the distances, right. Right? And you add them together. Could we say this distance is the same as the y-intercept? Could we say this distance is the same as the x-intercept?
Yeah.
Not it. Look at it. Look, it's negative, right? Distance is positive. So, if I want to make a definition or a rule about the height and base of this triangle, and I'm going to use the x and y intercept. The height of the triangle is going to be the absolute value of the y-intercept. The base of the triangle is going to be the absolute value of the x-intercept. The hypotenuse is going to be the distance between the two intercepts. Why don't I have to say absolute value there? Distance is always positive, but how am I going to find the distance? Distance formula. Won't that clean everything up? Because when you subtract the x's, subtract the y's, yeah, might be positive, might be negative. But when you square them, aren't the signs going to take care of themselves? And you root that, it's going to stay positive. So to say the absolute value of the distance is kind of being redundant. It's like painting a white fence white. It's like it's already white, right? Okay, good. I think I'm done.